The word extraction means basically it's not extraction like something you're extracting out. The extraction is a chemical reaction that basically involves reduction of a metal ore, mean it's a redox reaction. Metals are electron donors, mean they are reducing agent, and in any compound form they are in their oxidized form. And you want to get the pure metal, it means an oxidized form of the metal must be changed to reduced form. So extraction of the metal is basically a chemical reaction that involves reduction of metal back to the pure form, or reduction of the metal ore back to the pure form. Whether it is chemical reduction method or electrolytic reduction method, in both cases the metal basically in oxidized form must be into the reduced form. So that process is turning back a metal ion, basically oxidized form, to reduced form, the original form. Okay, and that is basically, we call it as extraction. Now basically the extraction method depends on what is the position of the metal in the reactivity series. If the metals are very reactive like group 1 metals or group 2 metals, they are way too reactive. Some group 3 like aluminum and beneath, very reactive metals, they are extracted only by electrolytic method. In reactivity series, we've discussed this thing. You can see the lesson for reactivity series and its applications, that basically metal, the position of the metal decide which method to use. The metal which are high in the reactivity series, they produce very stable compounds, difficult to decompose or difficult to basically, you can say, reacting with a reducing agent like carbon or hydrogen or carbon monoxide and getting the pure form. You need a way too high amount of the fuels. That's not feasible. We use electrolytic method for reactive metals. And we have seen all the extractions of reactive metals like lithium, sodium, potassium, magnesium, aluminum especially, from bauxite, aluminum especially, in the electrolysis. So electrolysis of molten compounds, you can find out, you can see the lesson, electrolysis of molten compounds, and you can find out how the aluminum is extracted from the bauxite, how the bauxite ore is located, and then it is crushed, taken off, transported, and then the purification of bauxite is an important issue because it contains a huge amount of iron oxide and then it is added with caustic soda, and all that lesson is discussed there. So the pure alumina Al2O3 is mixed with cryolite and its melting point is lowered, electrolysis is done, pure aluminum is at cathode then. So you will find this lesson there. Here in this particular lesson, we'll find out how the less or moderately reactive metals are extracted from their ores. Okay, when I say ore, it means it is an impure form of the mineral, impure form of the metal. Like sodium, very reactive metal it is. In the nature you will find sodium mainly in the NaCl form. We call it as rock salt. So rock salt, sodium chloride, no doubt edible salt, flavoring agent, a preservative, has its own uses. But to get sodium metal, we need sodium chloride, and sodium chloride in that particular sense is acting as the ore of sodium chloride. Like for aluminum it is aluminum oxide, the bauxite, and mercury it is cinnabar. These are the common names. Or zinc, it is zinc blende, ZnS. Or for lead it is galena. Or for iron it is iron oxide, Fe2O3 hematite, with plenty of impurities, especially of the sand. So these are impure form of the metals. They are compound form, the way they exist in the nature. Iron is not existing as a pure metal that you go there and take it off, mine it off and use it. No, it is being hidden by the nature in the form of its ore. So when the man got wisdom, they find out how to get the pure metal out of it. There are certain metals which are in the pure form, like gold was in pure form, and from ages it was, and it is so extensively exploited by the mankind that it is very less nowadays. Same goes with some other metals like copper, they are becoming less. Okay, copper is also to some extent in the ore form, some also in the original form, or easier extraction for the less reactive metals. But gold, native metal, genuine, native, as such it is present. But most metals, if they are reactive, little bit reactive, moderately reactive, very reactive, then you will find them in their compound form. And you need to devise a way to turn from compound form to pure form. and that pure form then later on you can process that, even refine that, or mix with other metals and use for. Okay, so in this particular chapter, in this particular lesson, we are going to see how less reactive metals like iron or moderately reactive are extracted from their ores. The basic idea is always, you can find out this flow chart, that in the nature they are present in ore form. Ore is located by the people, surveying persons, and they find out this ore is worth mining, it has some appreciable amount of the mineral, and then when it is graded as worth mining, then it is mined and transported to an industry. And after that, ore purification is done. So the physically attached plenty of impurities, as much as possible, they are removed. And then we select a method. As I said earlier, you can see the lesson for reactivity series to find out high reactive metal by electrolysis they are done. And electrolysis lessons covers that, how these metals are extracted from their ores. And here we are going to see moderately or less reactive metals, how they are extracted from their ores. So we are going to see how extraction is done for some less reactive metals, especially iron.